Hey everybody, this is Garrett from Earth and Time, and today we're in one of my favorite places in the world. Come along with me today and let's learn a little bit more about the geologic history of Lake Tahoe. Lake Tahoe is one of the most stunning places, I think, in the entire world, and it's all set up by the amazing geology here, which is really a story of faulting, of glaciers, of volcanoes, and all of that came together to create this natural lake here that, as you can see, is quite large. It is huge. So here's a nice view of Lake Tahoe in a map showing where we're going today. So we're going to start our conversation just here on the other side of McKinney Bay at Eagle Rock. We're going to come down, talk about Emerald Bay and glaciation. And then I'm standing right now at the Inspiration Point here. And we're going to come back up and we're going to go to the outlet for Lake Tahoe, the only outlet for Lake Tahoe, if you notice on here. And that's the Truckee River, and we're going to talk about the multiple volcanic events that dammed this up and how the Truckee River had to carve through it in order to drain Lake Tahoe again. So this is a nice view of Lake Tahoe. You can see how large it is. And here's some facts about Lake Tahoe while I'm here. So first of all, the water is so clear here, and here's a nice picture of that emerald nature, which we'll talk about at Emerald Bay a little bit more. You can see 67 feet below the surface, or roughly 20 meters there. It holds 39 trillion gallons. That's enough water in here that could cover all of the state of California in 14 inches of water. Can you imagine that? Over a foot of water. So I wonder what it would be for Texas. It's probably close to a foot for Texas. And it's 1,600 feet deep. So I want you to think about this for a second, how deep that is. That means the bottom of this basin, this valley, sits at the same elevation as Carson City, which sits way down below the Carson Range here. You can see where Carson City is, and the depth is 1,600 feet deep. It's the third deepest lake in North America. It's pretty amazing. All right, let's go explore some of Lake Tahoe. We're going to head up to Eagle Rock, do a short hike up there. I'm standing on the California side of Lake Tahoe in the Sierra Nevada mountains, which as I turn around here, you can see behind me. The other side of the lake is Nevada, and that's the Carson Range, which is basically a spur off of the main part of the Sierra Nevada mountains. So why are the mountains here? Well, it's a story of faulting. So it takes faults to set up this basin that we see in front of us. Now, in one of my earlier videos, we talk about the Genoa Fault Zone, and the Genoa Fault Zone is actually helping to set up those mountains way off in the distance out there. That's part of the Carson Range, which is a spur off of the Sierra Nevada mountains. However, there are a number of faults here on the California side, or the main Sierra Nevada portion of the mountains, that helps set up this side of the lake, and actually are important for some major events that occurred here. It's actually faults that help set up this basin and allow it to stay a basin and allow the lake to be here. So Lake Tahoe is among the 20 oldest lakes in the world, and that's because it's on an active fault zone, and the active fault zone continues to move the land out in the basin here down away from these elevated areas here. So it continually creates a basin for deposition to occur in. So it can't, like most lakes and basins and in areas, it can't fill up with sediment and disappear very quickly. And some lakes, let's say, take thousands of years. I'm not an expert on lakes, but from things I've read, some smaller lakes can fill in 1,000 years, maybe tens of thousands of years. However, Lake Tahoe is estimated to be 2 to 3 million years old. That is amazing. And that's because it's on this active fault system. The active faults really are on the west side or the California side of the basin. And what that does is it sets up a bit of asymmetry within the lake itself or within the basin. So we actually have the deeper part of the basin here on the western side, and on the eastern side it's a little bit more shallow, and so everything's sloping down towards us. Now, because there are faults here and there are active faults, there have been some interesting events that have taken place. One of those interesting events is actually a tsunami. Yes, you heard me correctly. A tsunami occurred here in Lake Tahoe. Because it's such a large body of water, you can actually create tsunamis. I was blown away when I learned about this. Sometime between 21,000 and 12,000 years ago, an earthquake occurred along this side of the lake. And what happened was, because that earthquake, a giant landslide came from this direction across this area that's known as McKinney Bay, which you can see in front of you here, which probably at that time the land extended straight across in front of me. All that land, all those rocks, all that soil, all that vegetation rapidly slid into the lake. So what happens if you rapidly move something into a lake? You create force, and that force becomes a wave. In this case, it became a tsunami, and the tsunami went across the lake and hit the eastern shoreline. Now, I've heard people suggest different heights. So in feet, I've heard 150 to 200 feet up to 500, 600 feet tall wave, if you can imagine that, going across here. So I'm probably sitting about 200 feet right now above the lake, and that means that the wave in any of those cases would have at least reached me, and you can see where I'm at up here in a house down here. It would have wiped out everything we can see, at least to this level, and maybe even higher. In metric, that's somewhere around 50 to maybe 200 meters of height on a wave coming from here in McKinney Bay, where he had the landslide, moving across and hitting the Carson Range with a giant tsunami. Now, because it's a closed basin, where does that water go? It can't just keep going and dissipate its energy like you see in an ocean, or just hit land and maybe have a little bit of a reflection. Here what ends up happening is a tsunami makes it all the way across the lake, and where does the energy come? It comes back here as a sesh wave. And so you end up, just like if you were to have a bucket of water rocking it back and forth, you end up having these waves rock back and forth across this basin. I imagine decimating everything where those waves were hitting with the amount of force that was coming through. There's a bathymetry map, which I'll show now. Here is a bathymetry map of Lake Tahoe, and one of the most interesting events that's happened here is they actually had a tsunami where McKinney Bay here collapsed due to an earthquake, and they think that set off this gigantic landslide, and you can actually see the blocks from the landslide that are miles and miles across. Really fascinating story. The fact that you can have a tsunami inside of a lake basin is fascinating. The question for me is, could this happen again? We know we have active faults here. We have one bay that's been created here. Could you get other bays created in other areas where you could have big landslides associated with earthquakes here? Very fascinating. Talked about the faulting part and some of the unique things that happen with that. Let's now go down to a place called Emerald Bay, and let's talk a bit about the glaciation story here, which becomes very important because that brings water here in the form of ice, as well as helps shape some of the valleys that we see. So now I've moved towards the southern portion of Lake Tahoe, and what I wanted to show you are a couple things here that I think stand out real nice, and that is what the rocks are made up of for a lot of the Sierra Nevada mountains. And what you're going to see here is a granite, and actually it's a quartz monzonite, and so it's very quartz rich with pieces of mica in here, and actually there's some lichen on this. And so this is what most of the Sierra Nevada mountains are made up of, or at least the core of the Sierra Nevada mountains. Now when granite weathers, it weathers in these rounded shapes, so they make these nice round boulders. But one thing to be aware of is as they weather, they make what's called grus. And grus is weather granite, and it's basically like ball bearings. So if you're ever hiking on this stuff, just be very, very careful, because I can't tell you how many times I've been hiking here in the Sierra Nevada mountains, and I've gotten on some of this grus and I've just ridden it down. Luckily I had pretty good balance, but just be aware of that. To quote the great Jeff Goldblum, life finds a way. Look at this pine tree growing out of a crack in this granite. See something new every day. So I wanted to stop here and introduce you to what the granite looks like that makes up the Sierra Nevada mountains, as well as introduce you to this concept of grus. It's just fun to say grus. All right, let's go down and check out Emerald Bay and talk about glaciation here in Lake Tahoe. All right, everybody, welcome to Emerald Bay, one of the most popular spots in Lake Tahoe. It sits in the southwestern portion of Lake Tahoe. And why Emerald Bay has its name is because the waters are emerald out here. This area here is especially clear because it's kind of shallow in this area, so it gives this emerald appearance, hence Emerald Bay. But what I want to talk to you today about, I want to talk about the geology that made Emerald Bay, because it's such a popular place that people come to visit. Big part of the story, the more modern story for Lake Tahoe, is the glacial story. So Emerald Bay is actually a glacial bay, and a glacier started, and I'm going to apologize, there's sun in this direction, started up there towards Dick's Peak and then worked its way down as an ice glacier. An ice sheet came down and carved out this valley between about 110,000 years ago to about 20,000 years ago or so. And what it did is it came down, it scoured this section out coming through here, and it deposited a bunch of what we call moraines, or the material is grinding off the rocks. It deposited as these edges, which creates a bay-like feature. And at the very end of the bay, we can see where there's what's called an end moraine, or the end of the glacier at the front part of the bay. So we can see it right out here. And so that's where the glacier came down, scoured, and deposited material out there in the bay. So as the glacier came down and started rolling down this way, coming down through here, all the way out towards the lake, the second it started hitting the water, it started melting and contributing water to Lake Tahoe. And so in that way, the glaciers that came through here not only scoured this area and reshaped a lot of what we see as the modern topography of Lake Tahoe, but also contributed to the water that was already here. As I mentioned before, Lake Tahoe Basin was set up about 2 or 3 million years ago, and once a basin forms, the second there's water introduced to the system, you're going to have a lake starting to fill up, and that lake continued to fill up for a long time, and then you added the glaciers in the last 100,000 years coming down in here. So here's a nice view going towards the source for the glacier that came down and actually carved out Emerald Bay. Let's go up to the Truckee area. So we're going to really explore a lot of the western portion of the lake. We're unfortunately not going to get over to the eastern portion. We'll talk more about the geology and history of Lake Tahoe in future trips out to this region. So they have this poster, and I apologize for the glare, on Lake Tahoe history, but one of the things that's interesting here is that actually shows what it looked like about 15,000 years ago in what was known as ancient Lake Lahontan. So here's Lake Tahoe today, and it drained all the way down through Reno down to this giant lake that filled a lot of, here's Nevada, and you can see where this map is for scale, this portion of California, Nevada, and there was a giant lake here called Lake Lahontan 15,000 years ago. So Lake Tahoe would drain down and fill Lake Lahontan. All that's left of that today is the Walker Lake and Pyramid Lake, and at some point I hope to do videos on Lake Lahontan. So behind me are one of the lava dams that helped set up Lake Tahoe and blocked Lake Tahoe's flow and restricted the Truckee River. Eventually the Truckee River would carve its way through these lava dams. There are 3 of these lava dams here, 2 that happen here in Rampart area. So we're just north of Lake Tahoe at this point. and we can see these nice basalts behind us. So two of these occurred about 2 miles north of the current north shore of Lake Tahoe, and then another one occurred about a mile down the road this way called Thunder Cliffs, which we'll take a look at. So one thing I want to point out while I'm here is you can see those basalts on one side of the road, and as I walk down through the trees here, we can see the towering cliffs of a basalt flow on this side. So volcanoes erupted in this basin and helped dam up Lake Tahoe, which helped it get as deep as it was. Real interesting seeing this. So you see one side of the lava flow here. I can turn around and you can see the other side of it. You'll see they have the main road here going into Tahoe. I think it's 89 that's through here. And the Truckee River is just on the other side of all this foliage here. And I apologize, can't get down into it, but we'll look at the Truckee River up at Thunder Cliffs. This is one of the big lava flows that helped dam the Truckee River and helped Lake Tahoe get as deep as it was. And as I said, there were two of these flows. In fact, you can see the cliffs way up there are also part of this volcano sequence. So, and that's hundreds and hundreds and hundreds of feet above me up there. Pretty cool to see. So here's a nice view of the Truckee River, the only outlet for Lake Tahoe, and we'll go up and try to park it where the outlet actually takes place. But I want to stop at this spot because above me are what are known as the Thunder Cliffs, and the Thunder Cliffs are a series of over 100-meter tall, a few hundred feet to several hundred feet tall cliffs that are from a volcanic eruption that actually helped dam the Truckee River here and actually help fill Lake Tahoe. Truckee River would find its way around these different dams. So there's the Thunder Cliffs dams, as well as the two flows that happen at Rampart, and the Truckee River would eventually erode and find its way through, and that's what we see today. So this is the only outlet for Lake Tahoe. There's lots of places water comes in from streams and runoff. However, all of it comes through here down the Truckee River, which is, because we're towards the end of the fall season, is pretty low right now. So there is some water here, but not a whole lot of water running through. Not what I'm accustomed to. But you can see this one outlet, and because there's this one outlet, there's a series of volcanic events here starting about 9 million years ago, and those volcanic events would dam up the river and allow the lake to fill even higher than it is today. It's said that there's actually shorelines on the hills that are 600 feet higher than the shoreline today. So those volcanic dams would block the Truckee River down at Rampart and at Thunder Cliffs and allow the river to rise. So I would have been underneath maybe 600 feet of water where I'm standing at today. Thank you all for joining me today and learning a little bit about the geologic story of Lake Tahoe, one of my favorite places in the world, a fascinating story, a beautiful place. I really hope you enjoyed this episode. I hope you learned something. I always learn something every time I come out and I come take you all with me. If you enjoyed it, please give it a thumbs up. If you'd like, leave comments down below. I love hearing from you all. And if you haven't already, please subscribe to this channel. Make sure to hit that bell for notification to keep up on all my adventures. I really appreciate all of you joining me, and take care.